Welcome to This Explainer. Today we're jumping right into Lesson ID STEM-AI-AI-Unit 03, Lesson Pack 03, AI Fundamentals, Misconception Check Video Overview. Exact title, AI Fundamentals, Misconception Check Video Overview. This is built for Grade 7 Introduction to AI. Unit 3, which is all about learning and machine learning. We're on a mission today to uncover the absolute truth about how AI systems learn and generate answers. We're going to look at how machines perceive the world, how they reason, and why it's absolutely critical that we human beings double-check what they tell us. Section 1. The AI Accuracy Myth. Are computers always right? Okay, let's tackle this massive myth head-on. Have you ever just kind of assumed that because an AI is a computer, its answers must be mathematically precise and automatically accurate, like guaranteed truths? It's a super common trap to fall into. We're so used to calculators giving us the exact right answer every single time we type in 2 plus 2, right? So when an AI spits out a beautifully written paragraph or a really confident-sounding fact, our brains naturally just want to trust it completely. But as you'll see, AI doesn't quite work like a traditional calculator. Assuming it does is actually a huge misconception. Section 2. Perceive, Reason, and Act. The OECD AI Cycle. To totally bust this accuracy myth, we've got to look at the evidence from the OECD on how AI actually operates in the real world. The Organization for Economic Cooperation and Development, or OECD, has this brilliant way of breaking down the fundamental elements of an AI system. Basically, every AI system uses a 3-step cycle. First up is perceive. This is where sensors collect raw data inputs from the environment. Second is reason. This is the operational logic that interprets all that data to meet a specific objective, and it eventually provides an output, like a recommendation or a prediction. And third is act. This is where actuators actually change the environment based on that output. Now, while sensors and actuators can be machines or people, the real power, and the part we need to watch most closely, lives right there in step 2, the operational logic. Section 3. Patterns versus guaranteed truth. Why AI isn't a calculator. So diving into that reason step, we have to see exactly why AI isn't just a giant calculator. The OECD research distinguishes between 2 main types of AI. On one side, we have traditional symbolic AI. This uses strict human logical rules to deduce a conclusion from a specific set of constraints. That's your calculator-style logic. But on the other side, we have statistical AI, which is where modern machine learning comes in. Statistical machine learning relies on finding trends and learning through patterns, inferences, and probabilities across massive amounts of data. And that means its outputs are probabilities, not guaranteed mathematical truths. It's basically making a highly educated guess based on patterns, and sometimes, well, those patterns can lead it astray. Section 4. The NIST Checking Tools, your AI Detective Toolkit. Because these AI outputs are based on patterns and not guaranteed truth, we definitely need a way to check them. That brings us to the NIST AI Risk Management Framework. NIST stands for the National Institute of Standards and Technology, and they've developed a framework to help us manage the risks associated with AI. Think of these 4 NIST functions: govern, map, measure, and manage as tools in your very own detective toolkit. You need these tools to verify an AI's output before you just blindly trust it. Govern is about establishing policies. Map helps you understand the context and the potential risks of using the AI in that situation. Measure is where you actually employ techniques to assess and verify those outputs. And manage is how you prioritize and act on the risks you found. As an AI user, you're basically playing the role of a detective, making sure the machine's probabilities actually line up with reality. Section 5. Classroom AI Check. Applying the framework. All right, let's look at a worked example and see how this plays out in a typical 7th grade classroom scenario. We're going to put our detective hats on and use the NIST toolkit. Imagine your class is studying geography, and you ask an AI for the capital of Australia. It generates this answer. The capital of Australia is Sydney because it is the most famous and populous city. Now, because statistical AI learns through patterns, it noticed that Sydney and Australia appear together online way more often than any other city. It deduced a trend. It looks super confident, it sounds perfectly logical, but remember our misconception check here. Computer-generated does not automatically mean accurate. This is exactly where we step in. If we apply the measure tool from the NIST framework, we are actively choosing to evaluate and verify this AI system's output for accuracy. We take this pattern-based output and we cross-check it against a trusted geography source. An atlas, an encyclopedia, or a trusted educational website. And when we do that, we quickly discover the AI is completely wrong. The actual capital is Canberra. The AI confused most frequently mentioned with the factual capital. Section 6. Your turn. Test it. Check the next AI claim. Okay, here's your challenge for a quick transfer task. It's your turn to be the detective. Imagine you're doing a health project and an AI finds some weird pattern online associating sugar with energy. It outputs this dangerously inaccurate health advice. Eating 5 pounds of sugar every day is a healthy way for middle schoolers to gain high energy. No way, right? So pause for a second and think about it. How would you use the NIST toolkit we just talked about, govern, map, measure, and manage, to prove this AI output is just a bad probability and definitely not a fact? Which specific tools apply here? Well, if you said map and measure, you hit the nail on the head. You would use the map function to understand the context, realizing that this is health advice intended for middle schoolers, which carries severe health risks if it's wrong. Then you'd use measure to verify the output against trusted scientific data, like medical guidelines or nutritional science, proving that the AI is basically hallucinating a really, really bad pattern. So, the absolute most crucial point to take away from this explainer is that AI is a wildly powerful pattern finder. The operational logic of machine learning is amazing at deducing trends, but its outputs are probabilities, not guaranteed mathematical truths. It is entirely up to you to be the human in the loop, using your risk management tools to verify the truth before you act on it. So I'll leave you with this. Knowing that AI learns through probabilities and not certainties, how will you choose to verify your next AI answer?